Okay, that should be the good one.
Okay,
All
yes,
right.
it's a good one. So, as I was saying, hello and welcome to everybody to this webinar about how to deal with minimum architecture constraint according to IEC, 61511 and 508. This is one of the many topics that we cover during this kind of events, and considering the good feedback that we received so far from the participants, we continue sharing our knowledge regarding intrinsic safety and functional safety. Brief introduction about myself. I'm Gabriele Caglio. I'm the technical support specialist here at GMI, and we have Tino van de Capelle, which is the expert and today's main speaker. As I was saying, I will start with a brief introduction of GMI. For whom doesn't know us, we are an Italian company providing field interfaces related to intrinsic safety and functional safety. So this means that it's possible to find GMI devices in many industrial packages, such as DCS, ESD, fire and gas, and so on. And as you can see from the screen, we are talking about oil and gas, petrochemical, pharmaceutical, mining, also food and beverage, and many other industries. We have about 40 years of experience in the field. The headquarters, I was saying, is in Italy, where we have our main facility and where we design, produce, and test all our products. We also have several offices and resellers all around the globe, so we are available pretty much everywhere. As I mentioned before, we are a safety company, and we aim to provide safety and reduce the risk of hazardous events to safeguard people, assets, infrastructure, production processes, and the environment too. So for this reason, the quality aspect of our product cannot be overlooked. We design our product, manufacture them, and test them 100% internally, meaning that we do not outsource any of these tasks. This is why we are confident about the quality of our products. Then a couple of quick more slides before to get the real part of the webinar. One is about the certificates that we have, or at least the certification body that we're dealing with. This guarantees the quality of the devices, but also guarantees that GMI products comply with the market requirements according to different local regulation. Another slide about our portfolio. So as you can see here, and as I mentioned, we have IS barriers, intrinsically safe barriers, safety relay, seal certified, with and without line monitoring for energized to safe or de-energized to safe application. We have isolators. We have AX power supply systems up to seal 3, temperature and digital multiplexer for zone 1 installation. We also have customized termination board for an easy connection between PLC and DCS systems. We have hard multiplexer, surge arrestor. We can provide consultancy and share our expertise also through courses related to functional safety and intrinsic safety. And the new series, the X1 series, it's a new concept, but it's something that we launched this year, and it's still a series of products that include IS barriers, isolators, safety relays, and hard multiplexer in one simple solution. The final slide before the start is a list of some of our customers, which stretch from system vendors to EPC, OEM to end user. And then the last thing, it's about this webinar. So this webinar is recorded. In a few days, you will find it available on our YouTube channel. If you want to get the notification, you can subscribe to the channel. You will get a link to download a PDF copy of this presentation. Again, in a couple of days from now, you will have a certificate for participating in the webinar, but only if you attend at least 75% of the webinar. And if you have any questions during the presentation, you can write them down in the Q&A session, and we will try to answer as soon as we can, and also immediately or at the end of the training. So I think we can start. It's
Good.
your turn, Tino, please.
Very well done. Also efficient. That's your 5 minutes of introduction gone. Good, Gabriele. So, topic for today is the minimum architectural constraint, which is a limitation, and how many subsystems or interfaces do you need to achieve what in safety. And this is driven mainly by the IEC 61511, but also for the manufacturers in the IEC 61508. We already, during your registrations, we received several questions where I had the freedom to select the most, let's say, interesting questions, which I thought can also have a value to answer that live. So I will do that at the end of the session. We have some presentation where we copied the questions, and I also already prepared some answer to that specific question. In the meantime, I opened here a slide which is called the IEC61508 life cycle. For some of you who have never been involved in functional safety, or maybe never have been working with some manufacturer producing some equipment like GMI is doing, and as Gabriele was stating, they had this list of all the certificates, and one of them is also called IEC61508, which is an assessment. This is made by a third party, in this case, to prove evidence on how reliable the equipment of GMI is. And the GMI people in the development team with hardware software, when they are developing either hardware and or software, which means firmware, then they have to follow specific steps to prove evidence. It's always about evidence to the accreditation officer or to the inspector to prove how reliable they are trying to build that equipment. This is a life cycle which I will save you, but we are looking here at numbers. There are numbers here 1 till 16, which are nothing else than life cycle phases. It's like an activity. It's some work that is going on in that specific activity. And as you can see over here, they start on the top with the concept, all the way till the bottom, till the decommissioning or disposal of that specific unit, interface, or system. All of this must be managed, of course, towards the standard called IEC 61508. And they do here a functional safety management, which is actually a kind of a quality. And as you have seen on the previous slide that Gabriele was mentioning, there was also some quality management system mentioned on there. Well, the functional safety management specific for the manufacturer is actually when they are developing hard and or firmware, they are following the 61508 quality management scheme, which is here called functional safety management. And again, depending on what level of SIL the interface is supposed to be used in, they need to prove evidence by the 61508 requirement that if it is a SIL 1 suitable device, then it will be an independent person requirement that needs to make that assessment. In other words, to make that expert judgment to prove evidence that this equipment can actually survive or can maintain a certain integrity to reach a SIL 1. If it is a SIL 2 requirement on that interface, then it will be an independent department. And only for a SIL 3, there is a requirement in the standard 61508 for an independent accreditation by an independent organization. And the independent organization is only a requirement for SIL 3. That mainly will lead, that investigation or assessment will lead into a result, into a report, and the report result may be then reflected into a piece of paper called certificate. And that's where the misunderstanding in the industry is coming from, that people are thinking we are buying a SIL 3 or a SIL 2 certified device. No, you are buying a device which is suitable to be used in a SIL X, and the certificate, which is the result of the assessment, will be reflecting what were the findings for that specific instrument or device. Even when GMI is developing, and I'm taking here as an example, for instance, their SIL 3 interposing relay, and when GMI is building a SIL 3 interposing relay, I can tell you now already, it will not be able, or it will not be achievable with a single contact enabled to remove the load to, for instance, your field device or to your solenoid. That means we call that the internal kitchen is typically more than one, let's say, contact that needs to be able to remove the power to the load. If one contact will not work, we want to have this other contact, it depending on the architecture, if it is normally open, normally contact, so it is either series or in parallel, or a mix of that. We call that, in the terminology of the standard, we call this HFT. And HFT, which you see here on the left-hand side, is standing for hardware fault tolerance. And you can ask yourself the questions, how many faults, danger faults, can I tolerate and still achieve safety? So the highest safety integrity level that can be claimed for any safety function will be limited, driven by a certain table, which is called table 2 and table 3 from the standard, which is the type A or type B table, which is also coming later on here in this webinar. And that will tell the, let's say, developers, how many HFT does that specific SIL X suitable device needs to be able to withstand. The minimum HFT will be driven, and we call this also here either the Road 1H and Road 2H. And later on in the webinar, which we only have here, 30 to 40 minutes max to train you on or to give you some information what is Road 1H and Road 2H. So I have done some slides where I have tried to summarize this in the hope that people will actually be able to understand this. The 61508 edition 2, which was out in April 2010, and there is a new edition 3 coming. It's not out this year. Hopefully it will be somewhere maybe next year. But we have an edition 3 coming up, and edition 3 is working with the same type of hardware fault tolerance or the same hardware safety integrity architectural constraint. And basically, there are two different roads still available today in the edition 2. One is called the Road 1H. And the Road 1H, basically, when GMI wants to develop a new product from scratch, it has never been built before, it has never been used before, it has never been proven before, then they will do their theoretical approach, they will do an FMEA, and they will come up with a certain, let's say, integrity estimation of that instrument, and they will follow something called Road 1H. And Road 1H is actually following that table type A, type B, or table 2 and 3 from the same standard as it was already in the initial edition 1 from 1998. Road to H is a different approach. Road to H assume that, for instance, a vendor has multiple instruments in the field in different applications, and they have very good failure track record or failure data. Well, then they can try to prove, based on feedback from real installations, what is the reliability that you can achieve with such type of instrument. We call that proven in use, which is here called the Road 2H. Of course, the question is, where does this data or failure data is coming from? Who collected that? What is the similarities with potentially my own installation, etc., etc. This type A and type B, which are showing here in table 2 and table 3, are two different tables. In type A table, you can see here we have a number 0, 1, and 2. That is the number of hardware fault tolerance that are minimum required to withstand, enabled to achieve a certain SIL class. And in the left column, we have something called safe failure fraction. And the safe failure fraction is either the built-in inherent safe design of your equipment and or the built-in diagnostics, which will be a percentage. And you can see the higher the percentage, the higher the level of SIL with a single device. The lower the safe failure fraction or the lower the diagnostic coverage, whatever is been measured here in the left-hand side table, then the more instruments I would need in a certain configuration enabled to achieve a higher SIL level. And they make a difference between a type A and a type B, because here in a type B, for instance, when the diagnostic coverage of safe failure fraction would be less than 60%, it's not suitable for any SIL. And that's here the difference between those two tables. Going into the 61511, which I can see here on the names, because some of your names I do recognize, and some of you are working for end users or for system integrators or for EPC contractors. Well, if you are building a process plant and you want to comply to the 61511, and in the process application, it's oil and gas, petrochemicals, chemicals, but also food and beverage and pharmaceutical. That's the kind of application that the 61511 is taken care of. Well, the life cycle for such an end user approach or for the process industry approach is different than the life cycle approach, but the principles, the backbone remains the same. Again, we will describe kind of activity in all those boxes, in all those phases. And we do have other webinars with GMI where we go more in depth in some specific phases. We also have to manage this in terms of function safety management. And somewhere in this life cycle or in this work activity, which is like a working scheme, when you are reaching here this block or this phase number 3, which is called safety requirement specification, that is the first time where the engineer will be asked, what hardware fault tolerance do you think you need to achieve a certain SIL level? And that's here the first time that this will become across let's say, the work activity, which is the safety requirement specification. And of course, once we are designing and engineering the system, this HFT will be the driving factor for me as an engineer to know how many instruments potentially do I need to achieve this certain SIL requirement. Once it is installed and commissioned, it is already too late there, because there it is already predefined how many would you have needed in able to achieve a certain SIL class. Assume that the HFT was wrong in the specification. It, of course, obviously will not be built, will not be installed, will not be maintained. That means the safety requirement specification HFT is quite important in any project, because that is where the first time it is set to say how many do we need. The 61511 has a different approach, different than, for instance, the 61508. The safety instrumented system, the design of it, the quality of it, is actually predefined again in that safety requirement specification, but we are measuring the HFT based on the level of SIL that you would need. We will have a simple table called table 6, and in that table 6, the main idea from the edition 2, which was our 2016/2017, if someone would be from the US time region, which I would doubt because it would be the middle of the night listening into this webinar, for the guys in the US, it's called the IEC61511, which is 2018 release, no matter where you're coming from. The 61511 today has a simplified table based on the theory that the end user has good quality feedback data. So this is not based on the data that the vendor like GMI will provide you, that is based on your own failure data. Because that's the whole idea about collecting field data from your own installation, with your own experience, with your own proof test, etc., etc., etc. Now, the 61511 prefers, and they call this prior use data, which is this quality feedback data coming from your own field, and not to use the safe failure fraction as per a subsystem like Road 1H. But at a certain point, you will see in the market there are different methods or are different approaches available. And in my training courses, I classically call those the method 1, 2, and 3. Again, method is not a definition from a standard. It's my own personal definition enabled to give the lectures or enabled to give my webinars. And we have 3 different methods that we will explain. I saw the question coming in, but I will pause it for a moment. I will first focus here on my slide. Method number 1 is the first option on the slide that you will see coming after one of those slides here, which will be purely based on Road 1H from the 61508, which is based on that famous safe failure fraction. Method number 2 is quality feedback collected by the manufacturers. That means the quality data needs to be coming obviously from the end users, needs to be fed back to the manufacturers, and the manufacturers can use that, and they will call this proven in use. When an end user or an operating company is using that data collection, quality data collection, we call this prior use. So both method 2 and method 3 is nothing more than feedback from existing installation, from existing equipment with good failure data record that you can prove. Not just verbally, you need to be able to show some evidence when there is a failure. Did you do a root cause analysis, or where is this data coming from? Can you show us the proof test, let's say intervals, data, coverage factors, confidence factors, etc. So all this question will actually be used enabled to give us evidence that you have good quality feedback data. Besides this Road 1H, which is the hardware approach, and the Road 2H, which was this proven or prior use approach, there is a fourth one, which I'm introducing here new in this webinar, because this webinar is repeated from a couple of years ago, and at that time, I did mention also Road 1H. Today, or in 2026, I see more and more evidence on kind of literature, data sheets, certificates, reports, vendor data, that vendors are starting to mix proven in use, partially, but also Road 1S. And Road 1S, which is the one here in the middle, this is actually called systematic capability. And there's a lot of confusion on systematic capability. And before the webinar started, I told this already to Gabriele, I'm getting quite frustrated to see all these experts called ChatGTP cut, copy, paste on LinkedIn, and also creating all this mass confusing about the systematic capability. So I told myself, enable to try to help the community, to give them some relevant data. Let's call systematic capability and also try to tell the people in a very short time call the webinar what this is all about. And again, believe me, I'm getting frustrated when I'm seeing all this posts on LinkedIn or social media, which is actually nothing more than people asking questions to ChatGTP, and believe me or not, it is not always correct. I tested myself just to prove evidence what is possible to achieve or not, even giving him the reference of the standard, even downloading the standard in an open source and tell him, go find me the right answer. Still, that is not possible. So please, when you are asking questions to ChatGTP, make sure that someone with a brain having a good reference called a standard will double check it before you start to use it in your industry. Because I see more and more people believing they are experts, but unfortunately, they are partially wrong in their assumption. So, summary 61508, which is road 1H, 1S, and 2H. It's a mix nowadays. Oops. 61511 is prior use, which is this road 2H. Here we have the Road 1H, which is the initial design of any new equipment. Again, during the Road 1H, they also, the vendors, like GMI is doing, they have a systematic capability of 3 on all their SIL 3 equipment today. Otherwise, SIL 3 would not be achievable. Road 1H can be a mix by some vendors when they take some quality data feedback from proved in use and Road 1H, and you will reflect this on the certification. Road 2H can be both prior use or proven in use. And summary, the overall SIL claim, the maximum SIL, will be the lowest systematic capability evidence on that specific device. Let me quickly make a pause here and look at this urgent question, all from the same person, having only 4 questions so far in 2 minutes time, so that's quite good. What are the key differences between the safety lifecycle stages IEC 61511 and the previous version that was already been existing? None, except one word. Software programming became application programming. So we say type the answer. No, we answered this live. That's done. What are the level of competency requirements personnel involved in the safety lifecycle activities? I will answer this later on, but briefly, everyone providing an activity in the lifecycle needs to be proven to be competent. The question is, how do you prove that? And again, I will come back on this in the Q&A. What are those documentation that is mandatory for each project phase of typical safety lifecycle? I need a couple of days to answer this, so I will say skip this. What is the difference between SIL determination and SIL verification? That's actually a good question. That's all depending on how do you understand SIL determination. When you determine a SIL, it's based on target SIL you try to achieve. When you verify a SIL, it is actually evidence to prove the equipment found that you will use in your safety loops by times of calculation on availability. That is called a verification. The other one is called the determination. All right. So we answered that in 1 minute, 4 questions. I bet you if you would ask ChatGTP, it's faster, but not necessarily correct. Table 6, coming back on the 61511. Here you can see the level of SIL on the left column will give you how many hardware fault tolerance do you need. That means for a SIL 1, regardless your configuration on redundancy or not, any mode means low demand mode, which is maximum once per year, high demand mode, which is more than once per year, or continuous mode. So any mode, you need an HFT of 0. That means you can build any SIL 1 according to 61511 with single loop design, which we will call a 1 out of 1. If it is a low demand mode, means less your unit under control. The hazard will happen less than once per year to activate your safety function, and it doesn't happen more than once per year. We call this low demand. Still, you are allowed to use a single 1 out of 1. But for a SIL 2, which is the high demand mode or the continuous mode, for a SIL 2, you need an HFT of 1. So here, minimum, you need to have a redundancy because you need to be able to tolerate one danger failure in your instrument loop. For a SIL3, no matter what mode you are after, it's always redundant. So SIL3 can never be achieved with a single device. And don't be misleading here. When GMI sells you a single relay, SIL3, that means the internal kitchen is taking care of the HFT based on the 61508. For you, it's still one single contact as a load that you will take the load away to your solenoid, but the internal HFT based on the 61508 will take care of that. It doesn't mean here you would need two SIL3 relays from GMI in able to comply. This is more here the SIL3. If you're looking to your field devices, like for instance your final elements, your solenoids, etc., that is where you would be required to have a hardware fault tolerance equal to 1. And for SIL4, which is ridiculous, they actually put this in a table. Why? Because SIL4 is not allowed to be used in the process industry. So why do you give a good practice or a good engineering practice in a table to call SIL4, where further down in the standard you say do not use SIL4? Well, I cannot explain, but I'm also not part of the committee any longer. Right, we have a first poll question for Gabriele to launch. What we want you to do is to read those questions, and only one is here the most correct and the most complete answer. There's no points to lose, there is no face to lose, but what I need to see is at least 50% of you is still awake. So I need to have 50% clicking on either A, B, C, or D. And the question is the architectural constraint as per 61511, that's the edition 2, can use either this method 1, 2, or 3, which was this road 1H or road 2H proven in use or road 2H prior use, but only one method per safety loop. Can use method 2 and 3 both based on road 2H, which is again proven and prior use. Oops. Can use only road 1H when claiming prior use for 61511. And answer D, can mix per safety loop all those methods together. All right, we need to do better than this because either you are reluctant to click a button or maybe you don't even bother. But I would appreciate if I get at least a few more because we haven't reached our target of 50%. And I go and strike if I don't get 50% response in my webinars, which is not good for Gabriele because then that means he needs to take over and start to talk. All right. Oh, we have 52%. So you're lucky, Gabriele.
Yes.
Come on. There are a few more.
Few more, yeah.
Yeah. But what I see is not so bad because the majority is clicking on the right one. There's a large group clicking on the wrong one, which is worrying. That means still there is a lot of awareness to do in the industry. Or maybe you could ask ChatGTP. This will be the job for today. Ask ChatGTP. I bet you they don't know the answer yet. All right, let's finish this, end the poll, and I will share the results. All right, so we had 38% clicking on the first answer A, that you can either use this road 1H or road 2H, but only one per safety loop. Well, that's absolutely wrong because you cannot build nearly, or you cannot find equipment that all have the same approach of how they have made the assessment on the equipment. So whoever is clicking here, don't worry. This is a very, very common, let's say, mistake in our training courses also, that people believe they either have to go this or this or this, but you will see that the other majority there, which is 46%, can say, oh, you can mix, doesn't matter. You can put a road 1H PLC in there, you can put a road 1H, let's say, safety barrier in there from GMI, you can put a road 1H safety relay in there from GMI, but I'm going to use a road 2H solenoid, and I'm going to use a road 2H with a mix of a road 1S, maybe valve, and I'm going to make a road 2H transmitter. That's what we do. Why? Because that's the only thing that is available on the market. It would be very easy for us if there would be only one method available, because then we can, we have no confusion. Unfortunately, that's not how easy safety systems can be achieved. Right, summary for you. What does this? Oops, I'm trying to close this poll. Okay. Summary, what does this HFT means in terms of architecture? There always this endless debate between production availability, because production people, they want to produce, whereas safety people, they want to keep it safe. And that doesn't necessarily goes hand in hand together. Typically, we as safety people always have to fight for our rights when we have a debate with our production people. And here I made a summary for you. The HFT 0, 1, and 2, which is actually the ultimate numbers that you will have to remember for the rest of your safety career if you want to be a safety engineer. The architecture for safety availability, when they ask for a 0 HFT, that means you can achieve that with a 1 out of 1. If you need an HFT of 1 for safety, then you need a minimum 1 out of 2 as a minimum, and I clearly state minimum. If you need an HFT of 2, then you need a minimum as a 1 out of 3. The right column goes hand in hand with the middle column. That means if production also requires a certain availability, the architectural for a production availability can also be a 2 out of 2, because then we will see later on they can have one spurious strip and still not tripping their production. When for safety reasons you need an HFT of 1, but production knows if one transmitter comes in and asks you to trip, you're losing your production, and that doesn't make production people happy, then typically on sensing, on voting, we will use a 2 out of 3. That means at the same time we can tolerate a danger failure, and at the same time, simultaneously, we can also tolerate a spurious strip. That's where we would opt or obtain for a 2 out of 3. With an HFT of 2, we need to have a 1 out of 3 from a safety point of view. But if production again doesn't want to have a spurious strip, then they will go for this 2 out of 4, because if one is coming in here to ask you to trip, you're losing production. If one of them is coming in here, you're not losing production yet. So with this configuration, you add on top of your minimum safety requirement, here you're putting in an additional production availability requirement. And the standard, I clicked again too much. There's something wrong with my touchpad today. It's much too sensitive. So the M out of N stands for the first N for mama. This stands for your number of independent voting channels. The last N for nothing stands for redundant channels, which are actually available, enabled to make a vote out. So for instance, when I have a 1 out of 3, I have 3 redundant channels. Only one of them is enough to achieve safety. Now, if I have a 2 out of 4, here I've got 4 redundant channels, but I need 2 in agreement before we're going to do something. I give an example here of a reactor. On the left-hand side, we are protecting here the inlet for the reactor with 2 fail to close valves. So the symbol FC stands for fail to close. The configuration is called a 1 out of 2. That means either one of those 2 valves can isolate the stream to the reactor to prevent the reactor from going into a hazardous event scenario, as an example. So if one valve doesn't work, but the other one still works, then we can still achieve safety. This one here, that's a great story for safety people. We are typically saying we are dreaming about that. We always want to have a secondary mean to shut down, because if one doesn't work, we have the other one that can enable, to shut our reactor down. This is the worst scenario for production. They hate that. They hate seeing 2 valves in the inlet, because they do know from production availability, if either one of them closes, they lost their production, and that doesn't make them happy. On the right-hand side, we take the same reactor, but now we're going to talk about in favor for the production people. That means to drain the reactor, we're taking 2 valves again, but now the valve is FO, stands for fail open. That means enable to drain this reactor, I have to open the top valve, and I have to open the bottom valve, enable for me to drain. Production people, they love that. Why? Because if one valve is leaking, they're not losing production. We as safety people, we hate that. 2 out of 2s for safety, we typically said forget it. Because either one of those valves, if this valve is stuck close, I can put 10 valves here below. I can never drain anymore. So again, this is the worst scenario for safety, this 2 out of 2, but it's the best solution for production. Opposite, this is the worst scenario for production, but it's the best deal for safety. And somehow we will have to combine those two. What I made here is a summary. What is missing on this slide, but to not overcomplicate it, this is purely looking from a hardware point of view. What is missing here is this Road 1S, which was a systematic capability, which I already briefly mentioned to you. But in the Q&A, I made a special slide to answer one of those specific questions that came in. So when I look here in this theory approach, which is the one over here, when GMI starts a new product from scratch, I can tell you now, those developers are using the 61508 as a guidance. And if it is a pure hardware device, like a safety relay with no firmware or software in there, then mainly they will use this table 2, and they will look into part number 2, which is called the hardware section from the IEC 61508. And in that section, there will be actually, this is here -2, which is shown over here, which is the hardware section. That means a specialist will make an FMEA, which stands for Further Modern Effect Analysis. They have to determine the safe failure fraction to come into the left column. In which row do we have to look to comply to a certain SIL? With what minimum hardware fault tolerance will I need? The same, they will need to prove evidence on the design quality. What is the systematic capability of such a device? Of course, they will have to define if it is a type A or a type B. And what is mandatory, not the certificate, but what is mandatory on an equipment is always a safety manual. And in that safety manual, to comply to 61508, the vendors are mandatory normative obliged to provide you a safety manual with all this data in there. Besides this, there will also be some estimate of availability of that equipment. So method number 2, that means now we are still with the vendor, but now we're looking from a collecting of field data from the field. They need to follow certain quality, let's say, standard guidance. And on top of that, they typically additionally will also make an expert judgment by doing some additional test. Not vendor related, but purely end user related. The end user collecting their own data. Well, the end user can use this table 6, which is the simplified table. So either prior use, but again, the end user needs to prove this, or the proven use, but again, the manufacturer needs to prove that. Both are allowed to use the simplified table. When this is not available, which is often not available in the market, well, then we are going back to the 1998 edition 1 method, which is still valid in edition 2, which is called the Road 1H. Good. I got another question. If there is a transmitter fault, for example, 2 out of 2, one of the sensors is an error fault or taking into maintenance override, should the logic architectural adjust voting to 1 out of 1? That's a very valid and also a very good question. We call this mode of degradation. I know some end users who mistakenly are remaining the 2 out of 2 voting block and are actually saying that, oh, we will just bypass or we will disable this one input and we will keep the voting block as a 2 out of 2, which is in my potential opinion a very serious mistake. So you have to degrade from a safety point of view. If you have a 2 out of 2 before, you need to degrade this into a 1 out of 1. That means the other healthy sensor, if this sensor is asking you to trip, you will trip. There is no other vote possible. Same when you have a 2 out of 3 and you need to calibrate, or there's one sensor in failure, then you need to degrade this 2 out of 3 into a 1 out of 2. And by the way, we have a specific webinar recorded on the YouTube channel from GMI dealing with this 2 out of 2 into a 1 out of 1, or with this 2 out of 3 dealing into either 2 out of 2 or 1 out of 2. So we have a webinar, but that's a very good question. So I answered this live. Done. Good. So let's summarize and let's keep on moving. Theory approach is Road 1H. Field quality feedback is needed for both proven and prior use. The big question is, who of you out there have good quality feedback data? Who of you is not using simply a database that you either found online or maybe asked ChatGTP, or maybe you bought a commercial database with some average generic failure data and you whack this into your calculation tool and you believe that you produce a verification report or a self-verification that is actually stating how available your safety system is. In other words, not many clients today have very good failure records or failure data. There are some, but they are very, rare to find in the industry. Okay, playing with a bit of architectures here for you. That's the second and last poll. No, the second last. There is one more poll. So that's a poll question concerning what is now safety availability versus production availability. And as I said, I'm playing here with a few architectures to play also with your brain to see if you can select the correct answer in here. A, 1 out of 2, 2 out of 3 are the same for production availability. That's your first potential answer. B, 1 out of 2 is better for safety availability than a 2 out of 3. C, 2 out of 3 provides both safety and production availability. D, 2 out of 2 and 2 out of 3 provide the same safety and production availability. And the last one, E, 2 out of 2, 2 out of 3, 2 out of 4, all architectures provide the maximum safety and production availability. Ooh, I must have scared with my theory the majority. Okay, now they're starting to click. Good. I told Gabriele I will sip my coffee, but now my coffee is really getting cold, so it's not drinkable anymore. Not well, I know you are Italian. You never drink cold coffee, I guess.
No.
But when you take a big mug of coffee, so it will last for an hour, it's clear. It cannot hold it warm. All right, let me see. How many do we have? Oh, we don't have 50% yet. So remember, I go on strike. So click on a few buttons. Doesn't matter if you click the wrong one or not. But try to click the right one, of course. Would be great to have the majority on the correct side and not on the wrong side. Which I'm not sure yet. It's ooh. We're moving. We're still getting people in. Come on, a few more clicks so that we can end this install and set the majority has it correct. Because it can still go both ways. We need one more click. And I hope this is the good click on the good side. Okay. No one. It's like an auction marked here. Oh, the click came in. And, oh, no. All right. So we're going to share this. As you can see, we have, well, there are people with different meanings here. And let me start with the bottom one, because the bottom one was a bit, well, it was obvious for me that this was misleading, and it is misleading. So this is certainly not correct, because 2 out of 2 has no safety availability. I just explained that. You have to, but you need to. How do you have safety availability? Because you need both valves to drain and able to drain your reactor. Or you do a 2 out of 2 voting between sensors, but both have to come in. So from a safety point of view, a 2 out of 2 has no safety availability for a very simple reason. If one of those 2 out of 2 channels has a danger failure that is not detectable, you will never be able to go to safety. So last one was wrong. That was the answer E. Then let's start on the top. A, 1 out of 2 and 2 out of 3 are the same for production availability? No, absolutely not. A 1 out of 2 has no production availability, because if one says, please trip, you will trip. But when you have a 2 out of 3 and one is coming in, please trip, you're not tripping yet. That means 2 out of 3 is better for production availability, of course, than a 1 out of 2, and are certainly not the same. 1 out of 2 is better for safety availability than a 2 out of 3. Well, that could be debatable. You could say in terms of reliability, calculation of PFD, etc., but purely based on HFT, they are identical. Both 1 out of 2 and 2 out of 3 can both achieve the same safety from an availability point of view. So 1 out of 2 is therefore not better, but is the same as a 2 out of 3 for a safety availability. And the only correct answer was here 2 out of 3 provides both safety and production availability. That's also what was explained in this one slide. All right. Oh, okay. I thought there was another slide coming, but we will open the Q&A in a minute. So what can we help you with? As Gabriele was saying, we do, besides training, we also do kind of consultancy services. Whereas lately, I'm more and more dragged into the last bullet here, is called the functional safety management assessment. We do from time to time still help some people to write some or helping reviewing some safety requirement specification. SIL determination and verification. It was a question of one of the delegates here today listening to the webinar. Well, either to determine the SIL or to verify the SIL. These are two different concepts. We also often are, or not often, we also sometimes still involved in LOPA, although LOPA, there are people buying these software tools where they all of a sudden become an expert because the software tool is dealing it for them. If not, they are chat CTP, jokingly. Last bullet is the 62443 lifecycle support. That is where it is a hot topic today in the market, because besides safety, you also have to do security risk assessment, which also, by the way, has a separate webinar here on the GMI portfolio. What I'm mainly involved in, and I just returned from the Middle East, where I just had another functional safety engineer training just before the Ramadan started. So we are doing this functional safety engineer program for here. We ran it for over, oh gosh, 22 years now. So we have trained, myself personally trained more than 3,000 plus people in 265, to be correct, different training classes worldwide. We do cybersecurity fundamental courses and also security risk assessment courses, which is my British native speaker working also with TVC, who is doing this. And of course, we're doing some customized training and webinars. The best book on earth is shown over here on display, which is the Safety Instrumented System. Jokingly talking about the best book. The book is very good, but the book is also being supported or sponsored by GMI, and there are thousands and thousands and thousands of copies floating in the market. Today we have the edition 5, and in the latest edition I managed, it was end of last year, or was it? No, it was end of 2024, whatever. I managed to write a new chapter called Functional Safety Management, which is chapter number 10. All right, let me swap quickly into the Q&A, which should be, oh, I need to share a different one. Okay, let me share this one now. All right, here we go. So we collected some questions, as we mentioned in the beginning of this webinar. How to deal with the minimum architectural constraint topic raised a few people by registration already to ask some questions. So what I did was I copied the question, and then I'm trying to give you a condensed answer. Dear Tino and team, could you comment on your stance while evaluating type A devices as per roads 1H or 2H and potential conflicts while mixing both approaches in the SIL verification? Thank you. If you remember, one of my slides was saying we are mixing this confusing in the market. Well, that is probably why this engineer who was registering for this webinar, and I'm not sure if the same person is online or not. Maybe he registered, but he's maybe not there. I'm not sure yet. But please, if you are here, well, then this is your answer. Type A devices as per road 1H or 2H and potential conflicts. There could be potentially some conflicts. You can mix them, but only if your individual subsystem justification can be clearly documented. What do we mean with that? It's not only the SIL number that a vendor will give you, the safety manual will have to tell you or explain you a bit more than just a stupid SIL number. It has to be told to you, what do you have to do to achieve or to maintain during your proof test or during the duration of your mission time? What do you have to do in able to prove that this system is still reliable in the, let's say, level of SIL you're trying to use it for? Systematic capability. Besides the SIL number, SIL is not talking anything about the quality of design. The systematic capability will reflect the process of the design or the rigorousness of design. So systematic capability is very, very important to, let's say, Be told by your vendor or be told by your user documentation what systematic capability can such a subsystem achieve or have achieved, because that will tell you or limit you the skill level that you can maintain in your plant. Also, you need to prove that the reliability, or the PFD, stands for the probability to fail dangers up on demand, and the average factor is here based on your proof test interval and your proof test coverage. All this theory estimation needs to be consistent on the specific subsystems. And I put here the last bullet: no cherry picking of favorable assumptions, because, in safety, we don't like to assume. Assume it will work when I need it. Assume the number that the vendor is telling us must probably be correct or not. Assumptions is not always a very good thing to do in safety. So we like to show or find some evidence. Road 1H and Road 2H are just two different justification philosophies. Mixing them is allowed. However, the overall safety argument must make technical sense and also needs to be justified by evidence. I hope I answered here with this question. Are there any requirements for qualification of personnel who makes up the scope of work for the system architecture? What do you think? Can you say anyone who can serve coffee can define how much hardware fault tolerance? Of course, we need to have competent people. And that's the whole idea about the competency review, which is the one that we are sponsoring through GMI in terms of training classes, by giving some, let's say, 3 days fundamental basics understanding of the standard, measure it with an exam to see how much did they understand of the basic fundamentals, and that will lead into an evidence. It's called a certificate, with nothing more to prove that you passed the minimum requirements of the exam of this program from TOV Rijnland, which is, by the way, the leading program in the world. I would say don't look anywhere else. There are many different competition on the market, but if you look in the number of engineers worldwide, the moment you hear that there are about 30,000 plus engineers certified or being proven compliant to the minimum requirements understanding of the standard, well, that is what the function safety engineer SIS for engineers have been about for the last 22 years. 61511 today, edition 2 and edition 1, had a specific clause, which is quite complex clause if you start to read it. And the clause is saying that any person, any department, or any organization which is involved in any life cycle activity shall be competent, including the person who is trying to define how many hardware fault tolerance or what is the architecture that you would need for achieving your certain SIL. That means you need to prove the identification of the required competency, most likely may be written down in the functional safety management of that specific organization or that specific company. Training, you need to prove that people are trained for whatever activity they are accountable or they are responsible for. You also need to prove that they have some experience. Of course, when you're coming, when you graduate from university or whatever, it's very difficult to show experience because you just started. So before we are actually letting people doing those activities in the life cycle, we want to see some experience. And of course, everyone needs to start from somewhere, but experience is also a record that we need to see as an evidence. Assessments of competency. You can say, and I'll just pick here a name, whoever is here shown. I can say, for instance, Francis. My name is Francis. I'm competent because my name is Francis. Now, who am I to say, I don't think, Francis, this is correct? I mean, this is not how it works. The function safety management judgment needs to judge how will he check the competency of their people. And of course, it's always the same. It's always, are people formally trained for that? Are people having experience in that? And are people proving they have knowledge of the specific topic or activity that they have to fulfill? That's why assessment of competency is a periodic requirement coming from the new edition 2 or the latest edition 2, which is new for 10 years now. But the latest edition 2 of the 61511 needs to prove competency by a periodic assessment to prove that the people will maintain their competency in whatever activity they are responsible or accountable for. That's the periodic review, which was the last bullet. If someone specified the architecture for your design of your safety system or loop, well, that engineer shall be formally recognized as competent under the company's functional safety management system. And by the way, there is another webinar recorded, which is called Functional Safety Management, which we will most likely explain you a bit more what is now the purpose of a functional safety management. This question triggered my mind when I was preparing these answers because of this wrong posting, which is active for the last 2 weeks on LinkedIn, in safety forum, whatever, or specific engineers who want to expose themselves. Well, how is systematic capability and SIL related? And I made the following summary, which is not made by ChatGPT, that is purely based on a 20 plus years of experience dealing with the standards. SIL on the left column here. Well, first of all, SIL and systematic capability are absolutely not the same thing. Okay, I repeat, SIL and systematic capability are not the same. How do we use that? If you look in SIL, a SIL number is an estimate of an availability of a mathematic probability calculation. We were using that PFD/PFD average or PFH enabled to prove how reliable this specific hardware is, but that's quantitatively, and that means you need data for that. Again, we have another webinar where I also went into more details on that specific topic. But if I briefly ask you the question, and I bet you money, some of you have university degrees, are masters in science, are master in whatever. But if I would ask all these university graduated engineers over here, if I would ask you, can you calculate for yourself when you will die? You would say, that's not possible, Tino. I would say, well, good. Why do you think you can do it on your instruments? Where does this data coming from? It's purely an estimate. We are trying to assume all this, that your systems will be available to a certain extent based on numbers. On the right-hand side, we have systematic capability. This is not based on mathematical calculations. This is not based on estimates. This is not based on assumptions. This is based on real facts to prove the process development quality. We have measurements in the standard in the 61508, which are the measurements from part 2 hardware, part 3 firmware software. And the measurements are about 400 measurements in 20 plus tables in those two parts of the standards. And they will have 4 columns, column 1, column 2, column 3, column 4. And the higher the SIL we are trying to achieve, the more rigorous in design we need to prove that we can control our failures in our design. And we can also avoid our failures in our design, and that will lead into a qualitative approach, which is purely process-based, to lead into a systematic capability. And the bottom one, I swapped those tables. The left-hand side is now reflecting the systematic capability. And please remember this. When you can find evidence from the vendor or on a certificate/report/datasheet, not on ChatGPT, that you have a systematic capability of 1 on that specific subsystem, make it easy and tell yourself you can only use that device for maximum SIL 1. That means if you ever want to go after a SIL 2 loop compliance device, make sure you find a device that can actually show evidence of a systematic capability too. Same for SIL 3. And yes, I also added SIL 4 in here, which is stupid, I know, but I put it in there just to make the logic complete. If you want to have a SIL 4, you need to have a systematic capability equal to 4. One more slide, last slide, I think. Let me look at the time. Oh, it's 12 o'clock. We're nearly on time. To achieve a certain SIL, 61508 put emphasis on SFF, while 61511 does not. Why do 61508 and 61511 take different views on this? That's a good one, because that question actually came up yesterday, again, on one of the forums. And again, that specialist on ChatGPT, or one of them, is saying 61511 takes care of safe failure fraction also. Well, unfortunately, that is totally and utterly wrong. And the main reason is 61511 committee members, addition to, they said, we don't trust safe failure fraction from the vendors. And the main reason, and I actually put it here black on white on paper, the main reason is, as there has been a lot of water under the bridge, in other words, a lot of conflicts, a lot of, let's say, fights between those specific groups, basically the 61511 committee, read between brackets certain country members without mentioning them, were absolutely against the use of safe failure fraction because they knew, and they were correctly, they were acknowledging that mathematic geniuses, when you look at this formula, look, when you see here, the safe failure fraction is a ratio reflecting the danger undetected failures hidden away in your subsystem. When this symbol is called lambda, when this failure rate lambda, danger undetected, goes low, the ratio of safe failure fraction will start to increase. However, those mathematics specialists knew when they put in here 1 million fits, and fit stands for failure in time, which is 10 to the minus 9. So when you put in a million fits and you put only 5 danger combination fits in here, I bet you money that your safe failure fraction is 99.999999 something. That means, since safe failure fraction was by some, let's say, geniuses misleading or manipulated in their favor to go to a higher safe failure fraction, the committee said, we don't trust that. It's about time, Mr. End User, since the year 2016-17, so it's 10 years now, that you start to collect your own data, which is a great story for an existing plant. But what do we do with a greenfield where we start from scratch? How do you get your data? Well, that's again going back to the 61508, and that's where we again have to trust, believe the safe failure fraction. So, second bullet, that is the reason why today the quality field feedback is the, let's say, the preference from the 61511. 61508 and safe failure fraction will always remain. It will not disappear, not even in the very near future. Why? Because any new product has no failure rate, has no, let's say, feedback data from the field. We will have to do the theory approach. We will have to do the FMEA. We will have to do the fits. We will have to do the safe failure fraction calculation. That is why it will always remain for the rest of our career in safety. Good. Last poll, last slide, and I'm done. Okay, Gabriele, you can launch the last poll question. Please rate our webinar. So we have the choice between D, not what I expected, C, poor, B, well, you can read yourself, positive or excellent. Okay, well, I see, Francis, you raise your hand, but thank you for raising your hand. That's probably a wave. Okay, how many do we have? Oh, we have lots of activities. Well, I'm glad you appreciated the information shared in this very short time. It's always a challenge to, to try to explain a story which can last for 5 hours into 25 minutes. But here, share the results. I click on this button. All right. Well, thank you for listening. Thank you for joining the webinar again. Thank you for GMI and Gabriele to give me the opportunity to do another webinar.
Thank you.
And I'm sure there are a few more planned in the remaining of the year. Thank you again, and see you next time.
Yes. See you.
Thank you. Bye-bye.
Bye.